Chapter 13 talks about output and input streams. The OS stream is short term for output stream is a class that supports output. We can say hashtag include iOS stream and namespace std. We have this insertion operator, which the OS stream provides the insertion operator known as insertion operator for converting different types of data into sequence of characters. Cout is a predefined OS stream object, which we declared as OS stream cout in the iOS stream library. In this example here, we see that insertion operator converts the string literal to characters, temporarily storing characters in an output buffer. When we say cout, double left arrow, double quotations, age, double quotations, we can display the age. So the system writes the buffer's output to the script. It means with this OS stream, which stands for output stream, we can display this age on the screen. When we say cout age years, it will display 9, which 9 is a number. So OS stream is used for output stream. We have iStream, which is a short for input stream, is a class that supports input. We have this extraction operator that is known as extraction operator. It extracts data from the data buffer. It writes the data into different types of variables. With the cin, which is the predefined iStream, is purely with the system standard input, usually a computer keyboard. So iStream is for input stream. This extraction operator is used for input. With the cin, we can get something from the input. When I say cin first name, I can get the first name. When I say cin student ID, I can get the student ID. The system puts the input characters into a buffer. The extraction operator reads characters up to the next white space, converts the target variable data, and stores the result into variable first name. The extraction operator skips leading white spaces. In this example, you can see with cin, we can get something from the user. When I say cin double right arrow first name, I can get the first name. When I say cin double right arrow student ID, I can get the student ID. So the extraction operator skips leading white spaces. We can also format the output. We have a manipulator, which a manipulator is a function that overloads the insertion operator or extraction operator to adjust the way output appears. Manipulators are defined in the IOMAN IP and iOS libraries and namespace std. In this example here, we have double miles. So the iOS stream and IOMAN libraries define several floating point manipulators. When a floating point number is output, the default number of digits to display is 6. In this example, when we say cout miles, it will display 765.426. The default P, which is the precision, is 6. If I say cout set precision 8 miles, it will display 765.4261. So now the P is 8. When you say set precision 8, you have 1, 2, 3, 4, 5, 6, 7, 8 digits here. If I say cout set precision 2 miles, then I will get 7.7 E plus 02. If I say cout miles, I will get 7.7.7.7 E plus 02. So you can see set precision is specifying how many decimal points you want to get. When I put set precision 8, I have 8. So starting from here, this is 1, 2, 3, 4, 5, 6, 7, 8. If I put 5, I get 5 digits. 1, 2, 3, 4, 5. If I get 2, I get 2 digits. So with set precision, you can specify what is the precision. We have different floating point manipulators like fixed, like scientific, like set precision and show point. You can see with the fixed, we can get exactly specific number of decimal points. When you say Cout fixed at 12.34, I'm getting exactly 1, 2, 3, 4, 5, 6 decimal points here. With scientific, you can get the scientific notation. Like when I say Cout scientific 12.34, I'm getting 1.23400 E plus 0.1, which that is the scientific notation for this number. With set precision, we can define how many decimal points we want. If I say set precision 3, I get, and the number is 12.34, I get 12.3. If I put set precision 5, I get 12.34. So with set precision, we can decide, we can specify maximum number of digits and number. If a stream has been manipulated to a fixed or scientific, it sets the max number of digits in a fraction only. For example, if I say Cout fixed set precision 1, 12.34, I get 12.3. If I say Cout scientific set precision 1, 12.34, I get 1.2 E plus 0.1. So with the show point, it shows even if the fraction is 0, it shows the decimal point and trailing zeros. Opposite is no show point. For example, if I say Cout set precision 3, I get 99.0. But if I put show pointer and I have 99, I get 99.0. So with the show point, it will display that point. So with these manipulators, you can set up your output. You can specify what you want to see on the output. We have some text alignment manipulators like setW, setFill, left and right. The setW sets a number of characters for the next output item only. By default, the item will be right aligned and filled with spaces. If I say Cout setW7 Amy, Amy will be displayed in a box of size 7. If I say Cout setW7 George, George will be displayed in a box of 7. You can see by default it goes to the right side. With setFill, we can fill the character C. We can use the character C to fill that box. If I say Cout setFill star setW7 Amy, it will put a box of size 7. This Amy will go to the right side, and everything else will get filled with stars. I could say Cout left setW7 Amy, and then the Amy goes to the left. And on the right side, we get spaces. So when I say Cout right setW7 Amy, you can see the Amy goes to the right. When I put the left, it goes to the left. With these text alignment manipulators, you can align how you can display a string in the output. We have the buffer manipulators, which we have NL and flush. NL inserts a new character \n into the output buffer and informs the system to flush the buffer. When you say Cout double left arrow NL, it inserts new line and flushes. So when I say Cout flush, it informs the system to flush the buffer. Flush means to reset, empty it. So it will flush the buffer. We have some input, a string stream. We say a new input, a string stream variable of type I string stream can be created that reads input from an associated string instead of the keyboard. In this example, we have a string, which is Amy Smith 19. When I say is a string stream ins and I pass user info here, I'm creating an input, a string stream. I have two strings. One of them is the first name, the other one is the last name. I have an integer user age. When I say INSS double right arrow first name, it parses the name and age values from input string. When I say INSS double right arrow last name, I parse the last name. So it will read Amy Smith. When I say INS double right arrow user age, I get 19. I could display first name, last name, and user age. In this example, you can see how we can use this iString stream. And then how we can parse this string using this operator. So we load this string inside this INSS. And then we read the first name, last name, and user age, and then we display it. You can use a string stream to process a line of input text. In this example, I have iString stream INSS. So I define 3 different strings: line string, first name, and last name. I define an integer user int and a Boolean input done. In this example, you can see how we can parse a string. Like we have this input done, which is by default false. So we say while not input done, which not false is true. We get a line, we load the line inside the line string. We clear the INSS. We pass this line string here to the INSS. And we use the str function. This will copy the INSS as a string buffer. We process the line. We say INSS double right first name. So this INSS is the buffer. It holds the string that we have, which does has the first name, last name, and age. We get the first name. We say if the first name is exit, cout exiting. Else we get the last name and we get the age. We display first name, last name, and age, and we stop. You can see how we can use this buffer to parse the string. The EOF is end of file. Input streams have a Boolean function called EOF, or end of file, that returns true or false, depending on whether or not the end of the string has been reached. In this example, we have is string stream INSS, which is an input string stream. We have the string line string and we have the string data. We ask the user to enter a list of names separated by spaces. We use the get line to enter line into line string. I pass this line string into this INSS, which is a buffer. I say while I can read from that buffer display. So when I get a string, I can parse them one by one and I can display it. This is how we can use it. In this example, it shows that how you can use this input stream example with the 4 phone numbers. We have this is string stream INSS. We have the string line string. We have 3 integers, 2 characters, and 1 Boolean. I get the line, I put it in the line string. I say while line string is not equal to -1, is valid number equal to false. I copy input to INSS string buffer. So this line string will get copied into my buffer. I try extracting area code. I say INSS double right arrow area code. If INSS dot code, then I will read the dummy character office code and dummy character 2, and then station number. If it's end of the file and dummy character is not equal to dash and dummy character. So in this example, you can see how we can use this to parse a string. How we can use this input string stream to get data and then to parse it. So first we copy that string inside this. We get this string. We copy the input string inside our buffer, and then we parse, and then we get the result. We could also use the output string stream. So an output string stream variable of type, all string stream can insert characters into a string buffer instead of the string. We have this str, which the OSTring stream member function of the string returns the content of an OSTring stream buffer as a string. So let's look at this example here. It's showing that how we can use an output string stream. In this example, we create an instance of OSTring stream, which is info OSS. This is output string stream. We have three different strings. We have an integer. I get the first name, I get the last name, I get the user age. I write the user output to string. I say info OSS double left arrow last, and then comma and first name. I write a space here, and then user age. So I'm writing this data inside the buffer. I'm reading the first name, last name, and then the user age. I'm writing the last name, comma, space, and then the user age into my buffer. I say if the age is less than 21, write minor inside the buffer. And then I convert this to a string using this str function, and I display it. So you can see how we can use this output, the string stream, and then how we can use this buffer to write data to it. In this example, we're writing a string, and then we parse it. This is another example that shows output string stream example. So in this example, you can see that we are using in this example, you can see that we have this function. It takes two doubles and one integer, and then we're defining the O string stream out SS. So this out SS is an instance of O string stream. So in this example, you can see that how we use this to write data to. We're writing this data, and we use the setW function to specify how many digits we have there, and then we write it to the buffer. And then we convert it to the string, and then we return it. So you can see how we can use a buffer to write data for input, and how we can use a buffer to write data for output. So we could also have file input. In this example, I'm including IO stream and if stream. So when I say if stream, INFS, I'm creating an instance of if stream. I have two different integers, file num1 and file num2. I say infs.open numfile.txt. If I couldn't open, if not infile is open, could not open file, return 1. In this example, I'm trying to open the file. This if stream is input file string. Is using for input. If I couldn't open the file, say could not open file. But if I could open the file, then I read two integers. I say inf is double right arrow file num1. And then I use inf is double right arrow file num2. I read number 1 and number 2. I display closing file, num file, and then I close. In this example, you can see that if you want to read from a file, you can create an instance of if stream, and then you can open the file. You can use this double right arrow to read from the file, and then you can load the data inside file num1 and file num2, and then you use dot close to close. So I can say cout double left arrow num1 file num1. I can say cout num2, and I can display this file num1 and file num2, and then I can add them together. So if you want to read from a file, you can use if stream. The EOF function returns true if previous stream operation reached end of the file. So this EOF indicates where is the end of the file. The fail function returns true if the previous stream operation had an error. In this example, we're reading a varying amount of data from a file. So this my file text, which has a variable number of integers. I say if stream infs. I create an input file stream. I say int file num. I create an integer here. I open the file. If I couldn't open the file, I return -1. I use this double right arrow to get the file num from this infs. So with with this command, this INFS is an instance of IFS stream. So when I say INFS double right arrow file num, I'm reading file from this object, and then I'm loading one number inside this. I say while not fail, display that number. So as long as it doesn't fail, I display that number and then I read another number. So if I don't reach end of the file, I say input failure before reaching end of the file. I close the file using .close. So in this example, you can see that this INFS is an instance of FS. I can load something from the file. I can use this .open to open the file. And then I can load data from the file using this operator. As long as I can read, I will display it, and then I read again. And then if I reach end of the file, then I close it. This is an example of how you can read from the file. There's another example that shows how many times a word appears in a file. In this example, I'm creating an instance of IFS stream, which is INFS. I have a string. I see out opening file, word file. I open this file. If not is opened, I could not open the file. I enter a word here while not in the file. This means as long as I'm not reaching end of the file, read the word. If it's not failing, if current word is the user word, add to the frequency. Then display the user word and then the current word and the word frequency. So then finally I close. This example shows how you can work with files, how you can create an object of IFS stream and then open the file and then keep reading from the file, and then finally how to close the file. There's another example here, which is figure 13.53. It's a program that reads business reviews from file and computes the average rating. So I want you guys to review that. We have some stream errors. A stream error happens when insertion and extraction fails, causing the stream to enter an error state. We have this table, which it shows different errors. We have good bit, end of EOF bit, fail bit, and bad bit. Good return stream, no stream errors. These flags are used to check if some problem is going to happen when you're dealing with files. So if those problems are going to happen, then these flags will turn on. I want you guys to study them. Example 13.6 is a parsing and validating input files example. So it's using the IFS stream, and then we have a string here. We open teams.txt, and then we say if not teams is open, it means if I couldn't open the file, then drop an error. I get a line here, and then this get line will lead a line. So I put it in TMFS, which TMFS is an instance of IFS stream. I say while not fail, keep reading. If fail, display the team name. Else, get the num losses. If team FS fail, display the name and wins. So in this example, you see how you can use this IFS stream, and then how you can open a text file, which in this example, the teams.txt contains this data. When you open this text data, you have a while loop here that as long as you don't fail, you read the nums wins. First, you get the team name, and then you get the nums wins. If the team fail, you display the team name, has no wins or losses. Else, you get the num losses. And then if the team F is not fail, then you display the names and wins. So in this example, you can see how you can load data from a text file, and then how you can process it. So this example shows how you can load the data and you can process it. We have this OFS stream, which is a short for output file stream. It's a class that supports writing to a file. we have some basic steps for opening and writing a file. This OFS stream altfs creates an instance of OFS stream. When I say altfs.open word hello world.txt, I'm opening this file for output. I can say if not altfs is open, this will check to see if the file opens successfully or not. I write the string hello world to the file with this altfs double left arrow, hello world end L. I can write this text to this string, and then with dot close, I can close. These are the basic steps for opening and writing a file. First, we need to open the file. Then, if we could open it, then we write it, and then finally we close it. In this example here, you see that we have this instance of OFS stream, which is outfs. I open this file. If I couldn't open display a message, I write hello and 1, 2, 3, and then I close it. This example shows how we can open a file and then how we can write to it. This outfs stream is used for output file stream. There are some examples in this chapter I want you guys to finish. This example 13.8 is a C++ example for saving and retrieving format data, program data. In this example, we have an instance of ifs string. We have a string. We open this file. We say while not is open. If we couldn't open, we display a message. If we could, as long as we could, we read a line, and then we push back that review, which the review is a string. We push that string inside this review list. The review list is a vector of strings. So in this example, we're reading data, we're pushing them inside the vector of strings, and then we close it. In the main function, we have a vector of strings. We have a string. So we call this read reviews, display reviews, and then it will process the data. So in this example, you see how we can use this ifs stream to read data, and then how we can process that data, and how we can load it. In this example, you see that we have a vector of strings and we have a string. We have different functions here that one of them reads the reviews, one of them displays the reviews. So it's very important to pay attention here when you want to read from a file. First, you need to create an instance of ifs stream. Then you need to open the file. You could check to see if you couldn't open display a message. Then you keep reading from the file, and then you can process it. Section 13.9 is talking about overloading a stream operators. We have this insertion operator, which is double left arrows. In this example, we have a class, a volt counter. So in this example, you see that how we can overload this stream operator. This is the definition of overloaded string operator. We say if candidate A is equal to candidate name, A count plus plus. Else if candidate B is equal to candidate name, B count plus plus. Else if candidate C is equal to candidate name, C count plus plus. Return star this. So in this example here, we have a constant string candidate name, so what is an array of strings? We have a constant volt in indices, which is an array of integers. I'm creating this volt count, which is the size of voice indices divided by size of int. So in this example, you can see that when I say counter, I have a for loop here. This counter is a volt counter. So if you look at the volt counter is a class. So inside this class, I have defined this insertion operator, and I have overloaded. So in this example, you can see that the definition of this insertion operator is here. It's taking a constant string candidate name, and then we have some logic here. So when I say volt counter, I'm creating an instance of volt counter. I have a for loop here. Inside this for loop, I'm defining volt index, which is an integer. And I'm passing this volt index as I here. If you look at the volt indices here, it's an array. This will give me a number, which I store it here. When I say counter and I put this operator and candidate names the volt index, the definition for that operator is here. The definition of that operator, it takes a constant string, and then it will compare that to candidate A and candidate B and candidate C. It will add to A count, B count, and C count. The A count, B count, and C count, they are initially 0. Whenever I add 1 to them, it will add 1 to it. So if this candidate name is candidate A, this becomes 1. If it's B, B becomes 1. If it's C, C becomes 1. I display this candidate names, and then I call the get result and I display it. In this example, you can see how we can overload and define this insertion operator. We can also define the extraction operator. In this example, this extraction operator is defined here. So this class is defining the insertion operator and then extraction operator. So if you look at the definition of this will add the name to the end of the line using the push function. This will copy the name at the front of the line to the front name and then remove it. So I want you guys to study this chapter. There are some labs in this chapter that I want you guys to finish.